Hello friends, today I'm going to discuss the Solr Sharding Scaling and fault tolerance topic for the Solr. So uh, basically this sharding, what happens is sharding is actually the distributing like the way of distributing the documents to the Solr cloud. So what sharding do is like it divides the documents for the collection into different it divides among the multiple shard, and it distributes those shard on individual nodes. So that's how Solr can distribute that processing of those documents for that Solr collection. So basically shard in the Solr is that the way it achieves the distributed uh, kind of processing of the Solr documents. So I'm going to cover how, how what would be the strategy for sharding, and how we can split the shards, and how it helps with the fault tolerance. Uh, so sharding is the very important like uh, aspect of setting up the Solr cloud. So I will start sharding plays an important role in scaling and high availability. Shard creation is highly depends on the hardware and the shard size. What it mean by depends on hardware and shard sizes. Let's say uh, we have the particular node type for the EC2 instance, or our um, any hardware on premises hardware we have. uh, we can only accommodate certain number of documents per shard based on the hardware capability, because Solr required a very large amount of RAM in order to cache the document for the better query performance, and it also depends on the shard size. So based on the type of hardware, we can only accommodate so many documents per shard. So what happen is when the query is fired, uh, the that query is distributed among all the shards for the collection we are querying for. So uh, we need to like define the proper strategy for sharding in such a way that each shard uh, has enough equal amount of documents to process. Because what happen is when we have the documented not evenly distributed across the shard, anyway the response time of the query would be the highest amount of time taken by shard in the Solr cloud. So for example, let's say we have these assume that we have the three machines, and each machine hosting one shard, a1, a2 and a3. And let's say we have this shard a1 has a 10 million documents, a2 has a 5 million document, and a3 has a 2 million documents. So uh, in this particular example, so the total time would be taken by shard a would be more, because it is hosting more documents. So despite the shard a2 and a3 respond fast, because of those shard have less documents, the query response time always depends on the time taken by shard a1. So what happens is when we fire the query, there is a per shard one thread run to solve the particular query response. So if particular shard has a more document, that thread has to scan more like a document to determine the matching document for the filter criteria for the query. So better to have documents equally distributed among all the shards. uh, so this is this is a very important aspect when we are setting up the solar cluster, solar cloud, sorry. So why why we need this sharding? So basically what happens is like when i- over the time in company the data grows, and so the index document also grows. So solar cloud help us to divide documents in shards on the solar node, so we can scale the infrastructure over the time. uh, Also we need more data to shard. Its size grows, we also require to split that shard further, because the shard size grows over the time. So we also need the capability to split the shard. That also solar 4.3 onwards, it helps to split the shard. So how actually the sharding works is like when we set up the solar cloud, we can specify the number of shards to set up for that collection. uh, so um, how it works is like, let me go to this, this. So there are a couple of sharding strategy, like we can, one thing is we can specify the number of shard at the time of setting up the solar cloud. So there are two strategy, like one is the auto sharding and one is the custom sharding. Auto sharding automatically distribute that documents among the shard using their own hashing algorithms. So each shard is allocated with the range of hash, and we can see that in the on the solar admin console on the cluster state.json. So as you see on the right side, that each shard has the range of documents for the given collection. Another strategy is the custom sharding strategy, where the client application that pass document for indexing to Apache Solr are primarily responsible for placing them in a shard. So each document has that unique key attribute, and shard key can be prefixed into that ID. For example, let's say unique ID, we if we want to route a particular document to particular shard, we will prefix that ID with the shard ID we provided, and we can like concatenate the document ID with that shard prefix. And exclamation operator act as a separator. So custom sharding also help like influencing the how the document will be stored, uh, like across the shard. So we can have a different strategy for our efficient use. For example, let's say we want to divide our all the documents based on the year month data. So we can prefix that with that year month, and when we submit the query, we can pass this prefix of the year month, which help us to route that solar query to that particular shard. Also we can specify the exact like where we can instead of hitting all the shards for the query, we can also specify the shard key as a query parameter. So it will help us to only route the query to particular shard which we passed as a key. uh, these features also help to like maintain the multi-tenancy environment and regional distributed search. uh, we can also specify like spread the tenants across the multiple shard by introducing another prefix for the unique ID, like dividing the shard key divide by number and then exclamation point and document ID. So basically these are the two sharding strategy we get, and we can like choose the based on the our architecture and design for the solar cloud. Another thing is like for the auto sharding, how I would go through this flowchart where how the Solr determine like how to uh, add the documents to the particular shard. So when we start the Solr cloud, we specify the number of shard, and we start indexing the Solr document to Solr, and it checks like is there any prefix for that. If it is there is no prefix, then it use the hashing to determine which shard that document will go to. Then it checks if the receiving machine is a replica or it's a leader. So it keep finding that what is the exact like correct leader for that shard, and based on that machine it index the document to that shard, and then that document is forwarded to the replica. So this is how the Solr helps to like populate the date like, documents in the shard. So as I mentioned previously that let's say after we define the number of shards, and over the time this when we keep adding the documents to Solr, shard size will grow, and we may require to split further those documents, further that split those shards into smaller shard, because uh, to achieve more parallelism while executing the query. So after Solr 4.3 onwards, Solr offer the capability to split the shard, and this strategy only works with the auto sharding. So what it do is like when we request this URL with action as a split hard, it will be it will divide the shard into the equal half, and it will deactivate the actual the original shard, and it's like the new two half splitted shard will be active. We can also delete the inactive shard using this request delete shard request. So how this split of the shard help is it reduce the size of shards, so we can further scale it those small shard, and it also helps to improve the performance of the query, because as I mentioned, per shard Solr runs one thread, and that thread has to scan less number of document to find matching documents. So it increases the parallelism, so it helps with the performance. uh, Another thing is um, and here is the actual image which represent how the split of the shard works. So originally there was shard 1, after split it becomes shard 1 underscore 1, shard 1 underscore 0. uh, so these two are the new splitted shard, and the shard 1 which was originally here it displays active, but in fact on the backend side it is not active, but on the Solr admin console it displays active. But so how this sharding help with the load balancing and fault tolerance is like, let's say when we maintain the replica of these shards on a different machine. uh, so let's say if one node goes down, all the hosted shard will go down with that machine, but when we have the replica of those shards, uh, we'll still able to solve the request for that collection, because there is a replica exist, and there are also when we use Solr J client, it offers the load balancing across the Solr cloud nodes, which also helps with the load balancing as well as the fault tolerance, because if the one node is not responding, it automatically try with the another replica to solve that request. So that's all for the Solr sharding and splitting and load balancing and fault tolerance. Thank you.